Let me start recording this session and start sharing my screen. Okay. Yes. So in today's session, we'll start now problem solving sessions. Okay, these are like mainly the problem solving sessions for the theory of machines. So today we'll focus mainly on the mechanisms and machines velocity acceleration topic. Okay, I'll quickly go through the what we studied in this two topics. One is mechanisms and machine. So we understood the definition. What is machine? What is mechanism? Okay, basically machine forms by the combination of mechanisms. Okay, which apart from doing some definite work, also transmits the available um, energy into some kind of desired work. Then we understood the different types of constrained motion, completely constrained motion, incompletely constrained motion, successfully constrained motion. We also understood the different types of pairs depending on nature of contact, lower and higher pair, depending on mechanical constraints, closed and open pair, and depending on the relative motion, whether it is a turning pair, sliding pair, screw pair, and so on. We also understood the different types of joints, binary, tertiary, and quaternary. Then the main topic we started, which is the degrees of freedom. From this, you can expect the problem. Okay, they'll ask you to find the degrees of freedom for a given mechanism. Okay, they'll give you the number of links. Okay, or some idea about it, and you have to come up with the degrees of freedom. So the general formula for a planar mechanism is this 3 times n minus 1 minus 2 times p1 minus p2. Okay, this is the Grabel's criteria. And when basically you have all the pairs with a 1 degree of freedom, this P2 will become 0 because P2 is a pair with 2 degrees of freedom. If you don't have any pair with a 2 degree of freedom, that will become 0 and your formula will become 3 times n minus 1 minus 2 times P1. And there are two more formulas, or let's say the alternative formula for calculating the degrees of freedom is this: F is equal to n minus 2L plus 1, where L is a number of loops. Okay, in your mechanism, how many loops are there that you have to consider here, and in order to calculate the degrees of freedom. And the last one is number of pairs also you can calculate. Then we talked about the 4-bar chain in detail. Okay, this is also very important. Grashopp's law. You can expect problems on this. They will ask you what kind of mechanism we'll get. Okay, whether we'll get a rocker mechanism, whether we'll get a crank rocker mechanism, or crank mechanism. You have to understand. First of all, in order to have at least one revolving link, the Grashopp's law should satisfy. That is, L plus S should be less than or equal to P plus Q. If it is equal to, then there is a chance that you will have a double crank or crank or crank rocker. But if it is greater than, always you will have a rocker. And if it is less than, then depending on which link is fixed, we have different mechanisms, right? So I'll just consolidate it in a minute. If length of shortest link and longest link is less than the other two, then there are three different cases. Which link you are fixing? Whether you are fixing the shortest link, then it is a double crank mechanism. If link adjacent to the shortest link you are fixing, crank rocker mechanism. And if you are fixing the link opposite to the shortest link, then you will get a rocker mechanism. But if length of shortest and longest link is greater than the other two, you will always end up with a rocker mechanism. Okay, we'll also solve one question based on this so that concept will be clear to you. And then if it is equal to, length of shortest and longest is equal to other two, then we have studied two examples of it. One is the wheels of the locomotive and the deltoid. Okay. Then we understood the concept of mechanical advantage. We also understood the concept of transmission angle. Okay, we'll also study a problem based on the transmission angle, so that things will be clear to you. Then we understood the slider crank chain, single slider crank chain. what are the different inversions and their applications, and then this double slider crank chain, their inversions and applications. Okay, so this is something we have studied in the first chapter. And in the second chapter, velocity and acceleration, what we studied? Write down heading. Give me 1 minute. Velocity and acceleration. In this topic, what we understood? How to draw the velocity diagram, how to draw the acceleration diagram. Velocity will have velocity of turning pair will be perpendicular, right? It will be perpendicular to the link, and sliding pair in the direction of sliding. Okay, in the direction of sliding. And if we talk about this is about the velocity, about the acceleration. If I talk about the turning pair, it has two components. One is normal acceleration and another one is a tangential acceleration. Tangential acceleration is all alpha, which is perpendicular, and this normally the centripetal acceleration towards the center, which is r omega square, and the resultant acceleration is under root of normal acceleration square plus tangential acceleration square. If it is a sliding pair, then it is again in the direction of sliding, whether it is in the direction of the sliding if it is acceleration, if it will be in the opposite direction of the motion if it is a deceleration. Okay, so direction or opposite to sliding. Okay, depending on acceleration or deceleration. Clear? And we also studied the turn slide pair. Okay? And whenever we have turn slide pair, you know, you will always have normal acceleration, tangential acceleration, acceleration of slider, that's there. But one more component will come, that is a Coriolis component of the acceleration, which is 2v omega. Okay, and we also studied how to define the direction of it. Okay, so this is something we have studied. We also studied the what you call instantaneous center method, eye center. Okay, and how to calculate the number of eye centers, n into n minus 1 divided by 2, correct? And solving the problem, this velocity problems by using the eye center method. This is also something we have studied. Okay, this is just a glimpse of what we have studied in the velocity and acceleration topic. Correct? So now let's focus on the problems now one by one. I just wanted to give you the quick overview of these topics so that solving the problems becomes easier. So today we'll focus only on this uh, analysis of planar mechanism. Okay, only this topic. The next class we'll discuss the problems on other topics. Okay. So I want you to be a little bit faster on this. Okay, so that we can solve as much as problems possible. I'll give you a question, and yeah, and I want you to solve it. Okay, so we have a 4-bar chain mechanism, 4-bar chain with a input link, which is, I would say, 50 centimeter, output link 30 centimeter, 6 link 60 centimeter, coupler is how much? 40 centimeter. Okay, type of mechanism is, what type of mechanism you will get? I'll not give you options. The options are like rocker, crank rocker, double crank, rocker crank. Okay, these kind of options. Think on it, try to solve. So this is one of the basic type of question you will get for 1 mark. Okay, I'll utilize this time to write another question. Don't worry, I'll give you the solution also, but I want you to spend some time. Okay. Tell me the answer for the first question. What kind of mechanism you will get? Very easy. First of all, Grashopp's law, apply the Grashopp's law. Check whether it is satisfying or not. Okay. So we have one answer here from Shrikant that it is a crank rocker mechanism. Okay. Let's first of all check it. Okay. So what is the longest link? Longest link is longest plus shortest has to and other two. Okay, we'll check the relationship. Longest is 60, shortest is 30, and is equal to the other two, right? 50 plus 40. So is equal to the other two. So there, this can be either uh, yeah. So length of a longest link plus shortest link is other two. Okay, so it's satisfying the Grashof criteria. Fine. So you will have a crank for sure. Now, which link is fixed? It's a special Grashof chain, you can say, because it's equal to which link is fixed? Shortest link is fixed, right? No, link next to the shortest link is fixed because this is your 60. Then you have input link, which is bigger. Okay, remember, only thing here, Srikant, is your input link is bigger and output link is smaller. Okay, and something like this. Okay, this is the problem here. Generally, the input link is smaller and output link is bigger. So you will have a crank rocker mechanism. But in this case, it's opposite. Here, your input link is bigger. Okay, this is your output link, and this is a coupler. Okay, so I would say the correct answer should be rocker crank. Okay, if they give you both answers, crank rocker, rocker crank, crank crank, rocker rocker, you should choose rocker crank because input link will rock and output link will crank. Okay, clear? Because our input link is bigger. If they give you opposite, input link is 30 centimeter and output link is 50 centimeter, then your answer is right, crank rocker. Okay, so sequence matters. Next question, can you solve? Next question. They are saying ABCD is a crank mechanism. ABCD is a crank mechanism. Options are like equal to 35, greater than 35, less than or equal to 35, and greater than 40. So yes, 45 is correct ballpark, Srikant. But can you specify whether it's a greater than 35, equal to 35, or less than or equal to 35? Less than or equal to 35 is also possible, right? So if I say it is a 35, what is the length of shortest and longest? Uh, so if I make it 35, then shortest and longest will be 85, and that is equal to the other two. Okay, and other two, right? And then the shortest link is fixed, so you will have the crank mechanism, right? And if I even make it as 30, then also it's the same thing. So I'll say it's a again AD is, you can say, less than or equal to, less than or equal to 35. Okay, because if I keep it 35 also here, what will happen? It will satisfy the Grashof criteria, right? 85 is sum of the other two links. Sorry, sum of the shortest and longest, and 85 is also the sum of the other two. And shortest link is fixed at 35, so you'll have a crank. And if I make it 30, then also okay. If I make it 30, length of shortest plus longest is less than other two. It is satisfying, and again we are fixing the shortest link, which is pure Grashof mechanism, right? So hence you can say it is again satisfying the Grashof criteria, and it's a you'll end up with a crank mechanism because you are fixing the shortest link. Okay, so this kind of questions you can always expect from the um, type of mechanism. Okay, I'll give you question on the now degrees of freedom. Let me go to the next slide. Okay, the question is, a planar mechanism consists of 5 links. Okay, a planar mechanism consists of 5 links and 4 turning pair and one, okay, and one higher pair having 2 degrees of freedom. Higher pair having 2 degree of freedom system. Okay, having 2 degree of freedom. The number of degrees of freedom of the mechanism is, what is the degree of freedom of mechanism? Try to solve this. It's not that difficult. Anyone? No? Okay, let me help you out with the solution. Yes. So yes. So what is the formula for degrees of freedom? One is the correct answer, Srikanth. Degree of freedom is 3 times n minus 1 minus Growler's criteria minus 2 times p1 minus p2. Okay, for a planar mechanism, this is the formula. Number of links are 5. Number of pairs with 1 degree of freedom are 5. Number of pairs with a 2 degree of freedom is 1. Okay, 1 into 1, 1 basically. 12 minus 10 minus 1, which is equal to 1. Okay, so degree of freedom is 1. Okay, easy. Um, a simple question: how many degree of freedom of a kinetic chain, sorry, kinematic chain, which with the single slider crank mechanism? So single slider crank mechanism, how many degrees of freedom are there? Single slider crank chain. How many degrees of freedoms are there? Single slider crank chain. 1. Okay, correct. Slider crank. ladder crank mechanism has how many degree of freedom? Ladder crank mechanism, 1 degree of freedom, right? Okay, let me check if I have any other questions based on degree of freedoms. Yes, I think I have one more. Okay, you try it as a homework. Okay, so find the degrees of freedom. Find the degrees of freedom of this mechanism. This is the question. You take it as a homework. Okay, answer is 0 in this case. Okay, answer is 0. Okay, spend some time on this later, and yeah, if you have any questions, then you can just make use of our WhatsApp group. Okay, let's solve some different types of question now. So this was specific to the what kind of mechanism you will get, what kind of what is the degree of freedom you will have, right? Now we will move towards little bit of different kind of questions where you will, yeah, you're supposed to calculate the maybe quick return ratio or velocity accelerations and so on. Okay. Okay. One question on the quick return ratio. We have double slider. Sorry, we have double crank type quick return mechanism, which is shown here. Okay, we have quick return mechanism shown here in the figure. Let me draw the figure. So this distance, the crank is fixed, right, in the return mechanism. And yes, this is 450. This is 100. Okay, this is 100. So yes, so the fixed link is 25 centimeter length. Input crank length is 50 centimeter. Output output length crank length is 100 centimeter. The question is quick return ratio is how much? How much is the quick return ratio? Try to solve this question. Not that difficult. Quick return ratio, you know, the quick return mechanism is used in the shaping machine where we want um, the forward stroke has to be faster, but return stroke has to be slower. Okay, so that because return stroke is an idle stroke, right? So we expect that the tool should return quickly. Okay, so basically, let me draw this in a better way. Um, okay, when this rod will come down like this, and is one extreme position, Okay, this is another extreme position. Okay, so now this is extreme positions are 50, 50, 50. This is the position of the so this is an alpha angle, right? It creates an alpha angle. Can also say this can also be alpha angle because alternate angles are equal. And now you can calculate the alpha angle, but the formula for quick return ratio is 180 plus 2 alpha divided by 180 minus 2 alpha. So this is the quick return ratio. Now the question is how to calculate this alpha. You already know this is 25. So alpha I would say sine inverse of perpendicular divided by hypotenuse. So sine inverse of 1 by 2 is 30 degrees. So quick return ratio is 180 plus 60 divided by 180 minus 60. So it is 240 by 120, which is 2. Okay. So you can say if it is taking 2 seconds for cutting stroke, then the return stroke will be 1 second only. Okay. So that is the actual meaning of it. Okay. I hope you are following. So remember, if question comes on quick return ratio, your main objective is to find alpha. Okay. Okay. Write down quickly. Okay. Um, give me 1 minute. Yeah. Another question. Yes. So this is about the velocity. I'll give a 4-bar chain mechanism. This is a 4-bar chain mechanism. We have link A, B, BC, and CD respectively. And link number 1 is turning with 10 radian per second. Okay. The question is for the mechanism shown in the figure, the velocity of instantaneous center of the link AB and CD is okay. AB is this. Okay. I hope you are following. Velocity of eye center of links AB and CDs. Okay. AB link is first link and CD link is third link. So eye center 1, 3. Velocity of eye center 1, 3. Okay. They are talking about the eye center 1, 3 velocity. So you know how to create the eye center. So eye center of that has to lie on this line, right? and similarly goes here. Eye center. We studied this, how to create this eye center. Okay. This is an eye center now for yeah, let's say for this, if I call this as a link number 1 and this as 3, this as 2 and this as 4, then this is eye center 1 3. Okay. If I call this as, let's say, I think while teaching I told you this has 1, this has 2, this has 3 and 4, then it is eye center 2 4. Okay. This eye center 2 4 I can say. Okay. So now, yes, what they are asking is velocity of eye center, angular velocity of this eye center, velocity of instantaneous center of A, B, and C, D. Okay, that let's call this point as a P or anything you can calculate. Okay, they have given you. Sorry, let me complete the question. The velocity of instantaneous centers of links A, B, and C, D is 200 centimeter per second. Then the angular velocity of link CD is. Okay, then angular velocity of link CD is. So omega CD is they are asking. Omega CD is they are asking. Okay. This okay, whatever. Omega CD. How will you calculate? Okay. Okay. So basically this you can assume this has one link and this whole has also one link, correct? So basically I can say this 10 radian per second. Using this 10 radian per second, the distance of point P to A is, let's say, X. I call this as X, suppose, because I know that 10 value. So I'll say X into 10 has to be equal to 200. This implies this X has to be 20 centimeter. So I got the value of X. Now I already know, let's say this is also given data. I have not given to you. This is 100 centimeter. The distance is given to you. A to D distance is given to you. That is 100 centimeter. So now I can say that x plus 100, okay, x plus 100 multiply by omega CD has to be equal to 200 because that eye center is common for both the links, right? So now omega CD has to be equal to 200 divided by 120, which will give me 5 by 3 radian per second. Okay, so answer is 5 by 3. Okay. So in this question, they are asking you omega CD. They have given you distance A to B, but they have not given you distance P to A. And this is the trick here. You have to use this to get X because you don't know the distance of eye center from point D. Okay, for that purpose, you did this. Okay, so this is an important trick. If you know this, then yeah, solving problem is quite easier. Okay, so I'll give you one more question, which is on the similar approach of instantaneous center. Okay, which I want you to solve. Okay. Can I proceed to the next slide? Okay, let's take a question. Now we have a Okay, so this is the point P. This is A. This is B. This is O. And this is C. First link is fixed. Second link, third link, and fourth link. Okay, so let's say this is a given mechanism. OABC is a 4-bar chain mechanism. OA is a 2 centimeter. AB is a 2.2 centimeter. BC is a 2.5 centimeter. And OC is fixed. Okay, OC is fixed, and that is equal to 3.5. Okay, OA rotates at 10 radian per second. PO is equal to 6 centimeter. PC is equal to 6.5 centimeter. The question here is, just a minute. First question, omega 4. Second question, radial acceleration of B with respect to C. Okay. So this is also they are asking you the angular velocity, and they are also asking you the acceleration, the radial acceleration of B with respect to C. Okay, so if you are able to get the first answer, second answer is also easier because radial acceleration is a normal acceleration, correct? And that is nothing but the r omega square. So BC into omega 4 square is a trick here, and you'll get the answer. BC is known to you, right? The only thing is you have to calculate omega 4 and put it here, and omega 4 calculation itself is your first question. Okay. So think on it. How will you solve? Okay. So P point is the instantaneous center for link number 1 and 3. I can say OA multiplied by omega 2 is equal to AP multiplied by omega 3, equation number 1. I can also say BC into omega 4 is equal to BP into omega 3, correct? So if I divide equations, these two, what we can do is omega 3 gets cancelled, and omega 4 we can calculate. OA is how much? OA is 2, omega 2 is 10, multiplied by BP is how much? BP is 6 minus BC is 6.5. 6.5 minus 4 is 2.5. B to P. Sorry. BC is 2.5. 6.5 minus 2.5 is 4 divided by yes. BC is how much? 2.5. And AP is how much? You have OP, which is 6, and OA is 2 centimeter. So 6 minus 2 is again 4. 2 gets cancelled. So I'll get it as 8 radian per second. I hope you are following. And we'll put it here, 2.5 into 8 square, which is 160 centimeter per second square. Okay, 160 centimeter per second square is the final answer. Okay. Okay. Next question. One more question I have. So you have 1 degree of freedom planar mechanism. Okay. We have 1 degree of freedom planar mechanism. Which of the following combination is possible? Which combination is possible? Okay. Which combination is possible? Options. We have 4 options. Try to solve this. 4 binary links and 2 ternary. 2 binary, 4 ternary, 3 binary, 3 ternary, 5 binary, and 1 ternary. Okay, try to solve this question. Okay, and okay, and after that you can solve this question. Okay, okay, I got disconnected from my mobile, so give me some time. So I'll not be able to see your messages for some time. So, but yeah, you can try solving it first question, and after that you can solve the second question. So in the second question, they're asking you the Corley's component of the acceleration. Okay. Um, okay. So they have given you the angular velocity of BC. And yes, you can use this as a, but they are not given you the velocity of slider. Your Corley's component acceleration is 2v omega. They are given you omega. Sorry, they are not given you the omega also properly. You need omega of 4, say this fourth link, okay, omega of AC and velocity of the slider. Okay, nothing is given. So this is also a good question, 2 mark question. Okay, before that I have given you this question about how many links we can have. Which of the combination? So degree of freedom, if you remember, the formula is 3 times n minus 1 minus 2 times p1. Okay, and how many degree of freedom they are saying? 1 degree of freedom, right? If we have 1 degree of freedom, then um, yeah, 1 is equal to 3 times n minus 1 minus 2 times p1. Correct. This is the formula you can come up with. And 1 minus 3n minus 3 minus 2 times p1. So 3n minus 2 times p1 is equal to 4, right? So yeah. Now if ternary joint is equal to the one ternary joint equal to 2 binary joints, right? So 2 ternary joints. So if I talk about say this, how many joints will be there? Ternary joints means uh, yeah. So first of all, okay, I think I forgot again one thing here. One for 1 degree freedom system mechanism having 6 links. 6 links are there. Okay, having 6 links. When you have 6 links, okay, how the formula will look like? N is equal to 6. So 3 into 6, 18 minus 4 is equal to 2 times P1. So how much? P1 has to be 7. So you should have basically 7 pairs. Okay. So 6 joints, sorry, 6 links and 7 pairs. So one excess pair you should have, right? So when you have 6 links, you should have one excess pair. Okay. And that is something I think we already studied, if you remember. So the combination will be 4 binary and 2 tertiary. Okay, I think this is the correct answer. 4 binary is you have and 2 tertiary. If you make this combination, you will have uh, basically number of pairs, effective pairs are 7 in that case. Okay, you can try this. I think the answer has to be option A. Okay, about the second question, this is a little bit tricky. Okay, so try to draw the velocity diagram in this case, so then you can easily solve it. Okay, so I'll just rub this. Omega 2 is equal to 1.25 radian per second. This we know. Okay, velocity diagram of this, I'll draw it in the red color. So perpendicular to this, and then because velocity of link BC will be perpendicular to that. Velocity of this link will be perpendicular to this, and velocity of slider will be in this direction. So this is Vs. This is my L4 omega 4. This is my L4. This is my L1. This is my L2. Third is your slider. And this is my L2 omega 2. Okay. If this angle is phi, this angle also has to be phi. So this is something we have studied, how to draw the velocity diagram for an inverted slider crank mechanism. So now velocity of slider, this is you want, okay, 2 v omega. So what is v? 2 into velocity of slider into omega 4 we want in short. Okay, so 2 into vs into omega 4. This is my Corley's component of the acceleration. So how will you calculate velocity of slider? L2 omega 2 cos of phi. L2 omega 2 cos of phi will be how much? If from this original triangle, L1 by L4, right? So L2 you know, L2 is 40, omega 2 is 1.25, L1 is 30, and L4 is 50, right? Because if it is a right angle triangle, hypotenuse is root of square of the other two sides of a triangle. Okay, so all this velocity of slider will get 0.3 meters per second. Now you want omega 4. So what is L4 omega 4? L2 omega 2 sine of phi, correct? It will be L2 omega 2 L2 by L4. So that will be, because yeah, it is a sine is like perpendicular divided by hypotenuse. So L2 is 40, omega 2 is 1.25, again 40 divided by 50. And if you solve this, you will get 0.8 meters per second. Okay, you'll get 0.8 meters per second. Now you got the value of velocity of slider. You got the angular velocity of link 4. So just put it here. 2 into 0.3 into 0.8. So that is 0.48 meters per second square. Okay, 0.48 meter per second square. Okay, this is the answer. Okay, any doubt, feel free to ask. Okay, okay, let me give you another question. Okay, this is about the turning moment. Okay, so calculating the moment. Let's take another question. A slider crank mechanism. Crank is perpendicular to connecting rod. Okay. Piston effort is 1000 Newton. Okay. What is turning moment? Turning moment in Newton meter. Okay. Crank length is given. Crank length is 20 centimeters. and connecting rod length is 100 centimeter. Okay, try to solve this question. Um, so I'll give you a glimpse of the diagram. Okay, so this is the slider crank mechanism. This is your point A, point B, and point C. Okay, this is R, this is L, this is theta angle, this is 90-degree angle, and this is a phi angle. Okay, so the turning moment is something they are asking you. Length of the connecting rod is known, 100 centimeter. Length of the crank is 20 centimeter. So try to solve this. So tan of L by R is how much? Tan theta is equal to L by R, right? So this implies theta is equal to tan inverse of L by R perpendicular divided by base is, yeah, if we calculate theta, you'll get it as 78.69 degrees. Okay, so from that you can also get phi, 90 minus theta, which is 11.31 degrees. You got, let's say, theta, you got phi, and now we can calculate the F rod. F rod is equal to piston effort divided by cos of phi, if you remember the formula. Okay, and then Ft, that is turning force, will be a sine component of it. F rod sine of theta plus phi, and then turning moment. Okay, I'm giving you all the formulation, is equal to this Ft multiplied by R. Okay, so now you got the flow. You first have to calculate the piston effort, which is given to you already in this case. Then from that you calculate the F rod, that is the thrust inside the connecting rod. After that, you will calculate the there will be two components of the load on the crank. One is tangential and the normal. The tangential component will create the turning moment. So yes, tangential component of the force you will calculate, and from that you will calculate the turning moment. Okay, so let's solve it now. What is F rod? Piston effort. Directly we can calculate here Ft. Ft will be 1000, okay, into sine of 90 degree. Theta plus phi is 90 degree, of course, in this case. So sine 90 is 1, divided by cos of. So in this case, basically your Ft itself will be your um, F rod. Okay, remember that in this particular case, because this angle is 90 degree, Ft itself is your F rod. So cos of phi, which is 78.69, So in this particular case, F rod and FT is same as 90-degree angle. Okay, because connecting rod and crank is perpendicular. So you will get FT as 1019 point cos of phi, right? Let me correct 11.31. So 1019.8 Newton. Okay, you got this answer. And then 1019.8 multiply by 20 centimeters, so 0.2 meters, gives you approximately 204 Newton meter as an answer. Okay, so the final answer is 204. Okay, so this is not that difficult. Only thing is you should know the F rod formula and FT formula, and from that how to calculate the turning moment. This is a very special case where your FT is equal to F rod because the angle between the connecting rod and the crank is 90 degree. Okay. Let me check if I have any other question. Yes, let's go to the next slide. In a slider crank mechanism, down in a slider crank mechanism on center, okay, on center, the crank length is equal to 25 centimeter. Crank length generally is referred by R. Okay, so if I directly say R is equal to 25, you should understand. Connecting rod length is generally L is 100. Connecting rod length is equal to 100 centimeters. Okay. Crank has angular velocity of 4 radian per second. Omega 2. Okay. Is 4 radian per second. Acceleration is 2 radian per second square. Okay. 2 radian per second square. Angular acceleration. Okay. In counterclockwise direction. Question is, when the piston is at the outer dead center position, first question, acceleration of slider is, okay, and the second question is angular acceleration of the connecting rod is. Okay. These are the two questions. Options are given, but here I'll not give you the option. Try to solve. So yeah, basically this is the sum situation. We have R, we have L. Okay, so this is the connecting rod and crank A, B, C, D. Okay, so slider crank mechanism, the crank length is 25 centimeter, that is R is equal to 25. Connecting rod length L, 100 centimeters. Omega 2 is known to you. And the acceleration of the crank alpha is also given. when the piston is at the outer dead center, it means extreme position, one of the extreme position they are talking about. They are asking about the acceleration of the slider, okay, for this position, and they are also asking us the angular acceleration of the connecting rod. So omega 2 is the angular velocity of the crank. Omega 3 is the angular velocity of the connecting rod, we can say. Okay. So if I talk about point B, R omega 2 is equal to, what is the velocity diagram in this case, first of all? Try to draw the velocity diagram and solve it. Let's say this is the fixed point, A and D. A to B, B to B is velocity, let's say like this, B. And C point is again perpendicular to it. Yeah. At this particular point, the velocity of the C is 0 because it touched the, it is at the extreme position, right? So I would say velocity of link AB is equal to BC in this case. So R omega 2 is equal to L omega 3. R is known to us, okay, which is 25, 0.25. Omega 2 is also known to us, 4, okay, and L is also known to us, that is 100 centimeter means 1, and omega 3, sorry, omega 3 you can calculate. So this implies omega 3 is also equal to 1 now. Okay, you got the omega 3. Acceleration of the slider. So you can, yeah, either calculate the acceleration diagram in this case to get that. To get the acceleration of the slider, yeah, you can draw the acceleration diagram and get it. But angular acceleration of the connecting rod is also you're supposed to calculate. Alpha 3, this is nothing but the alpha 3, and this is acceleration of the slider. Alpha 3, how will you calculate? Again, through the acceleration diagram also you can calculate. Or L alpha 3 is equal to R alpha 2. Okay, get this. Okay, when you draw the diagram, draw the acceleration diagram, then things will be more clear to you. Okay, I'll give you a minute of time. Okay, so this was my velocity diagram. This is my velocity diagram. Acceleration diagram we have to separately draw. So we have one point, A dash and D dash. The centripetal acceleration, sorry, the normal acceleration is this, R omega 2 square. Then we have a tangential acceleration, let's say, which is perpendicular to the link. Okay, I'm just randomly drawing it. Okay, we have space is in upward, so I'll draw it like that. R alpha 2. So this is my new point called B dash. Okay, A dash to B dash. Then we have yes, again centripetal acceleration. For BC link, we have centripetal acceleration L omega 3 square. Okay, and then we have the perpendicular to it is C dash. Okay, so that is alpha, C alpha, or L alpha 3, I would say. L alpha 3. Yeah, so this is the overall, this somehow the acceleration diagram will look like. Um, so the acceleration of the slider is a dash c dash. So a dash c dash, if you look, it will be r omega 2 square plus L omega 3 square you will get. Okay, so you have to add basically this length plus this length. Okay, that is something you have to add. If you remember why I am coming down, because acceleration of the slider should be in the direction of the sliding. That's why I'm turning it downward, not upward. Remember that. Okay, we want acceleration has to be in the same direction. That's why we are coming down here, and this is the point I'll get. So r omega 2 square plus L omega 3 square, if you add them, you will get it. So we have all the things 0.25 into 4 square plus 1 into 1 square. So it is 5 meters per second square. The answer for the first question is 5. And the second question is the angular velocity of the connecting rod, L alpha 3. So you can say L alpha 3 has to be equal to R alpha 2. So this implies alpha 3 is equal to R alpha 2 by L. So 0.25 alpha 2 is 2 divided by L is 1. So which is 0.5 radian per second square. Okay, so yes, this is how you can solve the problem. If you have any doubt in this, feel free to ask. Okay. Okay, I'll give one homework question to you, which you can try later. So we have one mechanism. This is A, B, C, and D. 25 centimeter, 40 centimeter, 50 centimeter. Okay, so a 4-bar mechanism is shown here. Link AB and CD are vertical. AB and CD are vertical. Okay, BC is horizontal. Okay, it's like a 90-degree between them. The input link has an instantaneous angular velocity of 0.2 radian per second clockwise. Okay, and angular acceleration is 0.1 radian per second square clockwise. The question here is velocity and acceleration of output link. DC. Okay, so the first question is velocity of the output link. Second question is acceleration of the output link. So it's a 2-mark question. Okay. Acceleration, that is alpha 4, 0.2 radian per second square is the answer. Okay. Velocity, that is omega 4 is 0.4 radian per second. Okay. So by drawing the velocity and acceleration diagram, you can easily solve. Very easy velocity and acceleration diagram you will get because two links are parallel to each other. Okay, you can try this later. Quite easy problem. Okay, let's go to some another question. Quickly write it down. Okay. E, A, and D. Okay, this is 20, this is 40. Okay, this is 40, this is 50. This is 3 radian per second. So let's okay, refer this 4-bar chain mechanism in this figure, and the input link AB has instantaneous velocity of 3 radian per second, already shown here. In this case, what they're asking is, first question is angular velocity of coupler. Okay, angular velocity of coupler is here BC, right? And second question is the output link. Okay, that is CD. Angular velocity of coupler and the output link. Okay, try to solve this question. Either you can draw the velocity diagram, solve it, or you can also solve it by using eye-center method also. That's also perfectly fine. Whichever you prefer, you can use this, use the method and solve it. Okay. Okay, I'll give you a minute of time. Okay. So let's try to solve this by using instantaneous center method quickly. If I say one, so this is eye center 1 and 2. Okay? Because in this case, this is a special case. Why I'm solving it by eye center method is, in this case, you have to, let's say, stretch these two and then get the eye centers, right? But in this particular case, it's not, because this point you're already bringing down here. So this is your eye center 1 and 2. This is the first link, let's say. This is your second link. Okay. First link, second link, third link, and fourth link. This is eye center 1, 2. This is eye center 2 and 3. This is eye center 3 and 4. Eye center 1 and 4. Your eye center 1, 3 is also same, and your eye center 2, 4 is also same. Okay, so that is something is making you easier to solve this problem by using eye center method, because you are already, like, because this 3 is already on the same line. Point B is already on the same line of AD. That's why it is eye center for the link 2 and 4 as well. Okay, so that's why I'm solving this by using eye center method. One distance from 1 2 to 2 4 into omega 2 Okay, 1 to 2, 4. So I'm talking about the point B. If I want to calculate the velocity of point B, it is L2 omega 2. So L2 is 1224 into omega 2, and that has to be equal to 14224 times omega 4. This is equation number 1. And 12223 into omega 2 has to be equal to 1 3 1 3 to 2 3 into omega 4. Okay, so from this omega 4 you can calculate 1 to 2 4 is 20. So 3 into 20 divided by 1424. 1424 is 6. End of 1 radian per second. And omega 3, sorry, here. Omega 3 is 1 2 to 1 2 to 2 3. That is again 20. 3 into 20 and again 60. Divided with 1 radian per second. Okay. Okay. So that's why this problem is quite easier to solve by using high center method. Okay. Okay. Okay, we have one question on the double slider crank chain mechanism. Okay, we have double slider crank chain mechanism like this. Okay, so this is my point A. This is my point B. This is 1 meter. Sliding down 3 meters per second. This is sliding towards right 4 meters per second. Okay, and yeah, it is making an angle theta. So double slider crank mechanism with a slider A moving with a velocity 3 meters per second and a slider B moving with a 4 meters per second as shown in this figure. If the length of the coupler is 1 meter, okay, and makes a theta angle with horizontal, okay, the question is what is the theta? How much is the theta? Calculate this theta angle. Okay, question is to solve this theta angle. Okay, let me help you out with the solution. So this IA, yes. So this is my A point, B point. What is velocity of A? Velocity of A is, let's talk about this instantaneous center. So we can assume this link is turning about an instantaneous center I. Okay. So VA has like 3 meters per second, has to be equal to this particular instantaneous. You can assume a single link rotating with an angular velocity omega. So omega into IA, correct? So this implies IA we know already. I think, let me check if I have that data is given. I think no, they are not given this. So 3, you can say is this implies you can say 3 is equal to omega times cos of theta, because cos of theta is base divided by hypotenuse. Hypotenuse is 1, and VB is equal to 4 meters per second. That is omega into IB. So 4 is equal to omega into omega sine of theta. Okay. So basically, if you take the ratio, tan of theta is equal to 4 by 3. Okay. This implies theta is equal to tan inverse of 4 by 3, which is 53.13 degrees. Okay, 53.13 degrees. So theta is 53.13 degrees. Okay. Another question. Yes, let's take another question. Okay, so this is 30 centimeter. So 120 centimeter, 90-degree angle. If for a slider crank mechanism shown in this figure, the angular velocity of crank is 10 radian per second. Okay. Okay, this is 10 given to you. Velocity of slider is something they are asking. Okay, try to solve this question. Try to solve this question. Yes, so the solution is quite simple. This is, let's say, okay, you can draw the velocity triangle here. Okay, this is the A, this is the B point, C point, and G point. I'll say A and G is fixed, correct? Then the velocity of B will be perpendicular to it. Okay, let's change the arrow. like this, for example, then that is r omega. Velocity of slider will be horizontal, and perpendicular to it will be the velocity of um, the coupler. So if this is theta and this is phi, it will change here. So basically this is 90. This will become phi and this will become theta, correct? Mm. So this not like that, I would say. Um, Velocity diagram. So basically this was the what do you call, this was your theta and this is 90 degree, and that's why this is phi, correct? Because theta plus 90 degree plus phi is 180 degree, so that's why it is phi. I hope you are following. This angle originally, so if I say your BC link was, I'm trying to draw this link here red and red, okay, so as to make you familiar. This was theta degree, okay, and now I just draw 90 degree. Similarly, I'll use a green color. So my this angle was phi, okay, and then we have a 90 degree angle to it. So this also, this remaining has to be theta now, correct? And this is 90 degree. So yeah, this is my velocity diagram. This is r omega, this is L omega 3, okay, and this is my velocity of the slider. So I can say by using sine rule, r omega divided by r omega 2 is equal to, or divided by sine of theta has to be equal to L omega 3 divided by sine of phi is equal to velocity of slider divided by sine 90 degree, which is 1. So velocity of slider is equal to r omega 2 divided by sine of phi, we can say. R omega 2, r is 30 centimeter, which is 0.3. Omega 2 is 10 radian per second divided by sine of phi, which is yeah, phi you can calculate. Phi is equal to, sorry, what is tan theta? Tan theta is perpendicular divided by base. Okay, that is tan theta is L by R. So that is 4. So theta is equal to 76 degree. Phi 90 minus 76, which is 14 degree. So sine of 4, sine of 70, sine of theta, sorry, sine of theta. Here it is phi, correct? Sine of 76 degrees. Right, so it will be 3.1 meters per second. Okay, so the final answer in this case is 3.1 meters per second. Okay, yeah, do this correction. I have written phi mistakenly, but it should be theta. Okay. Another question. In a slider crank mechanism, the stroke of a slider is 40 centimeter. Velocity of crank is 10 radian per second. In a slider crank mechanism, stroke of a slider is equal to 40 centimeter. Crank velocity of crank omega is 10 radian per second when crank is perpendicular to line of stroke. The velocity of slider in meters per second is the velocity of slider in meters per second is okay. So this is another question. We have a slider crank mechanism. Okay, this is the situation. This is crank and this is slider. Okay, O, or let's call it as A, B, C, and D. Okay, so this is the question. Stroke of the mechanism is how much? If length of the connecting rod is L and R is the length of the crank, stroke is how much? 2R, correct? 2 times the crank radius is the stroke. And how much it is given? 40 centimeter. So this implies how much R is given to you? 20 centimeters, which is 0.2 meters. Okay, so this is the given data. With the help of this given data, try to find the velocity of slider. Okay, you can draw the velocity diagram and get it. So this is point A and point D. Velocity of AB will be perpendicular to it. This is my point B. Okay. Velocity of BC will be perpendicular to it. Okay, C will be somewhere on this line, but point D will be again on the same line. So basically my point D has to be here. Sorry, point C has to be here, right? C has to be on the same line because my CD velocity has to be on the horizontal line. Okay, so that is possible only when the velocity of the coupler in this case is 0. Okay, velocity of the coupler has to be 0, and then only it is possible. Correct. So use this logic and try to solve the problem. Velocity of the coupler is 0. Okay, so I have given you the hint. That is, in this case, velocity of slider is equal to velocity of crank. Velocity of slider is Vs. Velocity of the crank is R omega. So that is 0.2 into 10, which is 2 meters per second. Okay, So answer is 2 meters per second in this case. Clear? Another question. Okay, we have 4-bar chain mechanism. And I'll just give you the dimensions. Fixed link 40 centimeter. Input link 20 centimeter. Coupler 50 centimeter. Output link 50 centimeter. Okay. Input link rotates at uniform angular velocity of 0.5 radian per second. Okay. At the instant when the input link is perpendicular to the fixed link and parallel to the output link. So input link is perpendicular to the fixed link. Okay. And parallel to the output link. Okay. Parallel to the output link. Determine the angular velocity of the coupler and output link. So this is the fixed link. You have 40 centimeter. Input link 20. And both of them are 50-50. Okay. So I'll repeat. If the input link rotates with an angular velocity of 0.5 radian per second, at the instant when the input link is perpendicular to the fixed link and parallel to the output link, determine the angular velocity of the coupler. That is omega 3. This is your omega 2. Okay. Omega 2. Omega 3 you have to find out, and omega 4 also you have to find it out. So this is the question. Try to solve it. Okay. Think on it how to solve. Very easy one. Okay. Let's solve this question. You can clearly see here input link and output link is parallel to each other. So velocity diagram, how it will look like? Let's say this is my A, B, C, and D point. A and D point is like this. Let's say this is my B point. Whenever input link and output link is parallel, your velocity of input and output link is same, and coupler has 0 velocity. Okay, your B and C will be on the same line, right? So I'll say input link velocity has to be equal to output link velocity. So that is L2 omega 2 is equal to L4 omega 4. Okay, this is my first link, second link, third link, and fourth link. L2 omega 2 is equal to L4 omega 4, and coupler link is omega 3 equal to 0. Okay, omega 4 is equal to L2 omega 2 by L4. L2 is 20, omega 2 is 0.5, L4 is 40. So that's why I'm not writing it as 0.2 and 0.4, because they, anyway both are in centimeters, so they will cancel out each other. So 0.2 radian per second is my omega 4, and my omega 3 is 0. Okay, so these are the answers in this case. Okay, I hope you are following. Any doubts so far? Feel free to ask. Okay. Another question. Okay, this is again a mechanism. This is 30, 55, 60, and 45. Question is, the mechanism shown in the figure is of type of mechanism. What is the type of mechanism? Options are given to you like crank, crank rocker, rocker, and none of the above. Okay, crank, crank rocker, rocker, none of the above. Okay, not that difficult, easier one. You can clearly see length of the longest plus shortest. How much? 60 plus 30, 90. Another two, 55 plus 45. How much? 100. So length of the longest plus shortest is less than the other two. So it's satisfying the Grashof criteria. Grashof mechanism basically it is. So it will have at least one rotating link, and the smallest link is fixed. Shortest link is fixed, and whenever it is shortest link is fixed and also satisfies the length of shortest plus longest is less than other two, you will have crank mechanism. Okay. Now, yeah, I think I'll take one or two questions based on the transmission angle, and then we will end our session. Okay, we are very close to the end of the session, so let's take one last type, which is transmission angle. A 4-bar chain, 4-bar chain has links of length 60 centimeter, 30 centimeter, 40 centimeter, and 50 centimeter, respectively. For fixed input coupler and output links. Okay, the minimum transmission angle is minimum transmission angle is okay. The minimum transmission angle is so. This is one by one. Okay, this is 30. Sorry, 60 centimeter. then 30 centimeter, then we have 40 centimeter, okay. So this is the mechanism basically. You can say this is 30, this is 40, this is 50. Again, this will be 30, so that overall it will be 60. Okay, so fixed link is 60. They have mentioning input link is 30. Then the coupler is how much? Coupler is 40. Output link is 50. So yeah, 30 plus 30 it will be 60. I think it's right. And what is transmission angle? This is your minimum transmission angle, right? This is how you will get the minimum transmission angle. Yeah, my minimum. You know the cases. So basically, this is for the minimum transmission angle. How the figure for the maximum transmission? What is the transmission angle? Angle between the output link and the coupler, right? You want the maximum transmission angle. What you will do? You will try to pull this here. Correct. So this is my 30. This will be my 40, and this will be my 50. Something like this you will do for the gamma max. Okay. This is for the maximum transmission angle. Right? Gamma max. Okay, just for your information. But in this case, the question is about the minimum transmission angle. We already studied this. Very easy question. How will you solve? Gamma minimum is basically tan inverse of, this is again perpendicular. So directly apply the tan theta, right? Tan inverse of how much? Perpendicular divided by base. So 30 degree divided by 40 degree. So it is 36.86 degrees. Okay, 36.86 degrees. Clear? One last question we'll take, that is about the maximum transmission angle. I'll go to the next slide. You are done with this. The last question. In a 4-bar mechanism, the length of fixed link, input link, coupler, and output link are 40 centimeter, 30 centimeter, 30 centimeter, and 40 centimeter respectively. Full stop. What is the maximum transmission angle in the degrees? Calculate it. What is the maximum transmission angle for the mechanism in degrees? Okay, as I already told you, let's say this is your starting point. For the maximum transmission angle, you will go to the left first. So you'll move in the left direction 20 centimeter. Okay, so fixed link is first of all. Okay, fixed link. The fixed link draw 20. Okay. Input link 30. You have to move in this direction. Okay. Then we have 30 is the coupler. Okay. So this is A, B, C, and D. Okay. Uh, I'll say this is link number one, fixed. This is input link, output link, coupler, and this is gamma max. So this is again 30 they are saying. Coupler is also of length 30 centimeter and output link is 40 centimeter. Now you got it. Figure is given to you. Try to find. Okay. Very easy problem. Can you tell me the answer just by looking into it? 90-degree, correct? Do you agree? Because one side is 30. This is a triangle. One side is 30. Another side is 14. This is 50. This is possible only when this is a right angle triangle, right? So some of the squares of the individual two adjacent sides of a triangle is equal to the hypotenuse, right? Hypotenuse square. This is our Pythagoras theorem, and based on that, you can tell it. Okay. So the angle is 90 degree in this case. Gamma max is equal to 90 degrees. Okay. So I hope things are clear to you from the analysis of the planar mechanism. Just to give you a quick overview, the major questions they can ask in this is, as far as the numericals are concerned, is calculate the degrees of freedom, what kind of mechanism you'll get, crank, rocker, crank, rocker, transmission angle, okay, mechanical advantage. Also, they can ask you directly using the formula. This is from the first topic. Theoretical questions will be based on the inversions. Okay, they will ask you the advantages and applications of the inversion and questions associated with it. They can also ask question on the quick return ratio. So these are the possible questions from the mechanisms and machine. Apart from that, velocity, acceleration, and problems can also be there. Okay, so and yeah, they will give you the figure, ask you to find the velocity of certain link, acceleration of certain link, acceleration of the slider, or so on. You have to understand whether the problem can be solved by using instantaneous center method or the velocity diagram and acceleration diagram. Coriolis component of the acceleration. So typical problem comes in the exam. Okay, you can see previous year question paper. Most of the time they ask Coriolis component of the acceleration. We also solved some questions on the forces. Okay, so what is the piston effort? How much is the thrust in the connecting rod? What is the normal, or what is the FT in the crank? Okay, uh, tangential component of the force in the crank, which creates the turning moment. Okay, so that question also, one of the question also we have solved like that. Okay, so this is a brief overview. What kind of questions you can expect from the exam point of view. Okay, some of the questions we already solved in the while studying this, and now yeah, we again focused on some more of them. Okay, in the next session, which will take probably next week, we will also discuss the questions on the other topics such as gear and gear train, flywheels, governors, okay, gyroscope, etc. So that these topics will be more clear to you. Okay. So yeah, that's all for today. Thank you all for joining this session, and let's meet again next week. Thank you all. Bye.